who did his BE from Computer Department we said. Good morning everyone. Myself, Sweet Rupani. I take this opportunity to welcome you all on the second day of FDP on NLP and Deep Learning organized by Department of Computer Engineering, Vidyavardhini College of Engineering and Technology. I take this opportunity to welcome our today's guest and our own alumni, Mr. Gautam Shende, who did his BE from Computer Department we said, and he did his MS in Computer Science from State University of New York at Buffalo. He is currently working as a software engineer at Google. We also have with us Mr. Sampat Chetty, who did his BE from Computer Department BTech. He is currently working as a machine learning developer at RX Logic. We also have with us Mr. Sameer Pathan, who did his BE in Information Technology Department of BTech. He is currently working as a full stack developer at Shadi.com. I welcome you all on the behalf of Department of Computer Engineering, and I request you to take over the session. Thank you.
Yeah, Gautam, you can now start.
Okay. So I guess I'm audible. How do I verify that?
Yes, you're audible.
Okay, cool. So I'm going to start sharing my screen. Is my screen visible?
Yes, it's visible now.
Yeah.
Okay, great. So today we are going to be talking about data science and machine learning development. I'll be joined by my friends Sameer Pathan and Sampat Shetty. We come from the same college, Vidyavardhini College of Engineering and Technology, and I feel honored to be presenting this today. So just a disclaimer before we start anything. We are not entirely experts in the machine learning industry or data science industry. We've been working for like maybe a couple of years. I did my master's, and then I've been working for 1 or 2 years. So by no means are we experts in the industry. So this is going to be an introductory talk, and we're going to be focusing mainly on applications. It's not going to be, since we already covered a lot of the main fundamentals and concepts in the previous seminar, so we won't be trying to go to repeat the stuff. We will try to make this more application based and more practical things, how we can implement data science and machine learning models with all the tools available right now. This is an entirely non-profit talk. We don't intend to advertise any links, products, services that we might use in our slides deck. Lastly, and most importantly, the opinions that we express in this talk are solely our own. These do not represent these do not represent the opinions of our employers. So with that being said, it's already been introduced, but we've already been introduced, but just so that everyone can hear us out. So I'm Gautam Shende. I did my master's in University of Buffalo. I did my bachelor's in Vartak, and I've been working for like a year and a half at Google as a software engineer. Currently, I work in the YouTube Kids team. My main work is in search and discovery, what videos are shown to the kids when they search for something, or what videos get recommended to them. So that's my team. Maybe Sameer, can you introduce yourself?
Yeah, hello. Am I audible?
Yeah, you are.
Yeah. So I
I did my graduation like Gautam from VSET in information technology, and I've been working for like close to 1.5 years now. And I work with People Interactive as senior software engineer, where basically I work as a full stack engineer, and my work involves writing front end code as well as back end and looking after the infrastructure and deployment and a lot of other things. And in this role, I get to work closely with machine learning engineers, product managers, data scientists. So yeah, maybe I'll be sharing some of my experiences that I've had in last 1.5 years. So yeah, that's it.
So
Sampat?
myself, Sampath Shetty. Even I have done my engineering from VSET in 2017. Since then, I have been working, like I have around 3 years of experience in IT with 2 years as a business intelligence developer in Infosys. And for the past 1 year, I have been working as a machine learning developer in a pharmacovigilance firm. And I'm still learning and exploring.
All right. So now that we've introduced ourselves, looking at the agenda for today, the first section is mainly going to focus around why data science, why machine learning, what's this all hype about, and once we've hopefully convinced you of why it all makes sense, I'll be exploring the KDD process, the knowledge discovery process in databases through more of a side project that I've been doing recently. So that again, it remains more application based. It's just not a whole bunch of formulas and theory that I present to you, but understanding it through a project, I think it makes more sense. And then we'll talk about the applications of machine learning. As Sampath said, he's been working as a machine learning developer, so he'll be sharing some existing libraries and frameworks. Then we'll cover some industrial aspects of machine learning. So how we want to cover here is like how development at in school and colleges is slightly different from development at the industrial level. You have to consider a lot of things like developing a scalable machine learning model, building models that work for millions and billions of users. So more on that, and eventually we will be sharing maybe something that we can do to cultivate a more a good environment rather for students. There are a lot of resources available online, and there's a lot of competitions that go on. So maybe we can promote some of that stuff to get students involved um, into these competitions and stuff. And eventually, if it's possible, we'll also try to. I don't know if it's feasible, but let's see if it permits. Then we'll also try to conduct an Q&A and to our best possible knowledge answer any questions there are. Okay, so beginning here. So why data science and machine learning? Well, one of the most obvious answers to this is that it is the hype right now. Data science and machine learning is absolutely everywhere. So you pull up an Amazon search page. So on the top left, you can see an Amazon search page. So you try doing this. Go to your website, go to Amazon.com, logged in, search for shoes, and then do the same from another logged in account, or maybe just open an incognito video and an incognito window, and then you'll see the recommendations and the search change automatically. So the underlying concepts here are built on data science and machine learning. Well, same for YouTube. This actually changes even for you on a different day. So basically, not even on a different day. Actually, if you search for Mumbai, maybe 1 hour or 2 hours later, the same result is going to fetch you a whole lot of different queries and a whole lot of different videos. So yeah, I mean, data science and machine learning is everywhere. On the left, it shows a news page. On Google, you go for Google News, and all of these are not only recommended through machine learning, but if you think of it, like each of these can actually make for a machine learning model or a data science model. For example, let's take an example here. This is something that I searched maybe I think yesterday and took a screenshot. So, is the pandemic getting worse in US? There are existing machine learning models to predict that. Let's say Trump rally So who's going to win the elections? The third news. So who's going to win the elections? There are machine learning models for that. And actually, you can pick any news, and you can actually build a machine learning model on almost everything. So yeah, it's everywhere. And when I say everywhere, it's literally everywhere. You take any product on the market. Say, you take any of the Google apps. Like I said, the YouTube search or Google search. Everything is built on top. Like everything uses machine learning at some point in the infrastructure. Take example of Airbnb. The listings that get shown to you. I actually read one of the papers. I don't remember the exact name, but it showed that how different models, different neural net models, different. Initially, they started off their recommendations with something that was not based on neural nets. I think it implemented something like I don't remember the exact algorithms. Maybe it was random forest or something, but it wasn't a deep neural net. But then they've been built an initial neural net, and that impacted revenues. And then they went on to a deep learning model, and that impacted revenues again. So everything, Pinterest, Facebook, Twitter, Amazon, Netflix, all of these companies use data science and machine learning. So yeah, yes, these are some of the reasons why machine learning. I'm going to go to the next slide and explain. So why there has been this shift to data science and machine learning. I mean, 10, 20 years in the past, there wasn't these concepts. So what was being used? And data science, if you look on the funny picture, to the funny picture on the right, data science and machine learning aren't really buzzwords anymore. They are actually something that get implemented on a large scale and that make a lot of companies a lot of revenue. So just a simple example to begin with. So let's say you're trying to buy a house. So you could build something that's based on if-then rules. So before machine learning and data science, we used a lot of systems that were actually based on if-then based rules. So if the price of house is this, then I'll buy. If it's not this, then I'll do something else. Something along those lines. So if you take a look at the graph at the bottom, so on the x-axis we have the number of bedrooms, and then on the y-axis we have, just for simplicity, some price in millions in Indian rupees. So maybe a studio apartment costs 50 lakhs, one bedroom is 60, 2 BHK 70, and so on and so forth. So a very simplistic model here would be based on if-then rules would be that, okay, let's say the price of a house is below X rupees per square feet, then it's maybe a good house. And you can then plot that line, which goes on linearly according to whatever value of X that you select. That maybe 1,000 rupees per square feet seems like a good option to us. So we can have that line, and then this can be an if-then based model. But this is very simplistic. And then in the real world, it's not really that easy. Like just look at what house is 100,000 rupees per square feet and buy that house. No, it doesn't work like that. There are a whole ton of factors that you need to consider. So what are some other factors that we could consider in this case? So these are just some examples of what other factors that we could consider. So one of them, like let's begin with average price of houses in that locality. So there's a good reason if let's say there are 2 or 3 other houses around the same house that are way cheaper than the house that you are considering, then there's a good reason that you should investigate that whether you should be looking into those houses, because that's an indication that maybe this house is overpriced. Some other parameters could be past prices in the locality. So if the prices in a locality are going down, then it doesn't make sense to, it depends really, but a simplistic answer is that it doesn't make sense. Like maybe last year the price of a property was 1 crore and now it is let's say 80 lakhs. So it doesn't make sense to invest in such kind of a property right now. So also condition of the house. So a house at 1,000 rupees per square feet or versus a house at maybe 1100 per square feet. One house is like, on a scale of 0 to 1, one house's condition is the maximum, that's 1. The other house is kind of has broken walls, has broken windows, and it's 0.5. Just because it's 100 rupees per square feet cheaper doesn't mean you need to buy that. So there's a whole lot of dimensions that you need to consider apart from just the price per square feet, and this list goes on. And then as these features scale, as you get tens, 20s, and hundreds of features, it becomes very hard to write very fixed if-then rules for such kind of a system. So this is where data science and machine learning actually make a lot of sense. So you could use data science for actually understanding the housing market, performing visualizations, what needs to be done, which kind of data you need to extract, which kind of variables make the most sense, and then fitting a machine learning model on that. A simplistic, like we could take the example previously, like you could, let's say that these are the most ideal features that we want to collect. So you could fit a machine learning model on all of these all of these features, and optimize some kind of y value or output value, example value of a house, like whether a house is actually worthy of paying maybe 10 lakhs or 1 crore or not. Okay, moving on. A few more reasons why machine learning and data science are so hot right now. So take the example of, in the industry, some topics can be really sensitive. For just to take the example of, like I work in YouTube Kids, so we can't show any random videos to kids because the policies, the legal aspects, those are very sensitive and complicated when it comes to when you go to that age group. So, and these kind of so we have millions and billions of videos. So if we were to actually hand out each of these videos to an individual or to a lawyer or someone who understands the legal technicalities, it could cost us exponentially. So this is where machine learning models make a lot of sense, where we can implement a machine learning model that actually understands with some degree of accuracy, like maybe the accuracy is 80%. But if it understands that even to some extent that these are the videos that definitely they do not follow the legal policies, then we could eliminate a whole chunk of videos, even if that means that we are removing some good videos. But as long as the model can predict with a good confidence that these are some bad videos, then we can actually reduce the size of the data set. And then it makes sense to send those videos to somebody who has the expertise to determine that, okay, then they can take a look, and then the cost reduces. Like, we're not sending 1 million videos now, we're now sending maybe 1,000 videos, and that is still a more reasonable approach. And also in today's environment, like it's become very competitive. The users want everything that they can in their applications. For example, take some music application, Spotify, Pandora. So as soon as a user gets one of the features in one application, they kind of start expecting same features around different applications. So if you're not implementing those, if you don't have good recommendation systems, if you don't have personalized experiences, then it's very hard to survive in competitive environments. Just for an example, recently, I think this was in 2019, Starbucks. There was this news that Starbucks started implementing reinforcement models for suggesting users what they want to get. So not since we are still in the introduction, I won't dive too much into what reinforcement learning is, but it's just an agent reward based system where, in this case, you can assume that if your system predicts something that the user likes, for example, I like cheeseburger. So if the system if the system sorry, there's some background noise. I'm going to try to clear that out. Yeah. So if the system So if the system is suggests a burger and I actually like burgers, then that could be that system, that recommendation gets rewarded, and it's based on that. You predict something, you're rewarded, and your parameter values are tuned accordingly. And then McDonald's in late 2019 also acquired a company that's a dynamic yield. So basically, they also started suggesting products, or rather food, based on the weather. So as the topic of or the highlight of the slide is the title of the slide is an ice cream on a freezing night. Who likes to have ice cream on a like? I give you one application that suggests like the temperature is 5 degrees Celsius, and that's suggesting you ice creams. I mean, you may be. I mean, this just a simplistic example. Some people do like ice creams on chilly nights, but let's say the other application suggests you a hot coffee, or maybe a hot chai. So people are going to be using the other application more. So I hope I've managed to convince you enough by this point that machine learning and data science make a lot of sense, and it's being used entirely in the industry. Well, if you're not convinced yet, maybe we're going to be trying even harder in the slides to come. Summarizing, data science is something that you can use to run huge aggregations. So you can run different aggregations and understand your traffic. So for example, you could perform some kind of map reduce to map reduce is it is kind of an aggregation model that helps you perform some aggregations. I don't know how to explain it in a simplistic way. Maybe at a very simple level, at a very high level, what MapReduce does is it will perform some aggregations for a huge chunk of data. So it will help us analyze how many users we have. Like if we have millions of users, then I want maybe thousands of servers. If I have billions of users, maybe I want 10,000s of servers. So data science is actually very helpful in actually understanding what kind of traffic I have, what kind the size of the traffic that I have. So it also helps so what kind of traffic I have. What do I mean by that? Like what kind of geographical diversity I have. Do I have traffic from cities? Do I have traffic from suburbs? Accordingly, I can build a system around that. And machine learning, on the other hand, is mainly it will help you build models around that data. So you want to keep your customers happy. Well, it makes sense to have personalization. You don't want to be showing rock and metal music suggestions to someone who's looking out for Kishore Kumar music. And it doesn't really. It's not only to keep customers happy. It actually also keeps actually also keeps the company happy. So there was a recent study that in 2019, I guess 93% of the companies that observed a year-over-year revenue growth, and that the companies that actually beat their targets, they were using some kind of personalization, some kind of machine learning AI in their models. So it's become very essential at this point to survive in the industry. Okay, so I'll be beginning with data science, and then we'll be moving on to machine learning. But I just want to start off with saying that everything in this AI world is actually connected. There's a whole chunk of overlap between data science, between machine learning, deep learning, artificial intelligence. We feel that linearly it would make sense to actually explain data science first. So that's how we're going to start with our presentation. Since data science is kind of one of the better ways to understand your data, and once you understand your data, it makes a lot of more sense to then build your machine learning models. Because in machine learning, it's very important to build your data, to understand your data before you start building models. Otherwise, it can be really inefficient. And we are going to be diving deeper into that as we go through the slides. Okay, just just taking a look at the time, it looks like it's 11:30. Okay, so okay, starting off with data science. these are like the high level steps in knowledge discovery, and then I'll be explaining some theory of it initially, and then I'll be jumping off to one of the side projects that I've been working on recently, and then I'll be trying to explain that with examples so that it's more obvious. And as I said, we are trying to keep this talk more application based and keep it more uh, keep less theory and less formulas and stuff like that. So yeah, these are the high level steps. First, you need to select the data that you want to process, and then you want to do some pre-processing on it. Then you want to transform the data mining, evaluation. I'll be explaining each of these individually as we go. So it's very important to actually selectively extract the data that you want to extract. You can't just build a model by extracting everything that you have by just extracting everything that's available. Just for example, if you're I'm going to be talking about a Twitter model in the slides to come. So if we are just extracting all the Twitter data that's available right now, Twitter generates about used to generate rather about 8 TB of data in 2011. That's per day. So if you're thinking that you have a 2 TB a 2 TB hard drive, and I'm just going to extract everything, store it there, it's not going to work, because if you see like 8 TB per day, I mean, of course, that's all of Twitter's data, but even if you're taking a fraction of it, and that's in 2011, I guess that number's maybe 10x or 20x by now, or even more. I'm not sure, but even if you're taking a fraction of that, your model is going to be highly inefficient. You're going to be you'll run out of space, and then let's say even if you are able to fit that amount of data, let's say you have a 10 TB hard drive, but then building models around that it's going to be really hard, because it's going to take hours and days to train your model. So if you want to refresh your model, then it's going to be like one day. If let's say your model builds in 1 or 2 days on a 2 or 3 TB size of data set, then if you want to refresh your model, and refreshing of models is not really an uncommon problem. Like, you need to refresh your models pretty frequently. So that is going to take you 2 or 3 days now. So everything basically becomes inefficient. So it's very important to actually select the data that you want to extract. And to select the right kind of data, you need to have the right domain knowledge for it. So for example, if you want to develop a COVID-19 project, then you need to actually do some kind of research that, okay, I'm looking at COVID-19 data. So maybe I want to base my model right now on US data. I want to base it on just the March. I want to limit my time frame for March and April data. So you need to understand the domain, and then you need to develop certain filters based on the domain knowledge that you've acquired. So some examples just here include like the time frame, the look. So in case of tweets, it could be something like time frame. I want tweets from X to Y date. Then location, I just want United States tweets. Then the keywords that I want to use. For example, if you're looking for COVID data, you want to look for COVID-related keywords, something like pneumonia, something like new cases, etc., etc. So summarizing, it's important to extract. It's important to have a good understanding of your data, have good domain knowledge about your data, and then only extract a chunk of what you want to extract, and not entirely extract everything that's available, because that's really inefficient. And so what can you do for extraction? So there's different mechanisms that you can, there are different mechanisms for data extraction. Some of those, so we'll be covering these in detail later on, but just to give a high level overview. So web scraping is one of those approaches. What web scraping is basically, let's say you're looking at some data on some dashboard online, like Worldometer. That's one of the dashboards for tracking coronavirus cases, or maybe some Maharashtra government website that generates a table of how many cases there were in different cities in Maharashtra, so on and so forth. So you can write scripts in Python, PHP, or any scripting languages, and then extract that data out from there. Other options that there are. This option is of course tedious, and it's actually prone to breaking, because maybe tomorrow the Maharashtra government changes its URL. So now you're not going to be getting any data. Maybe and then web scraping actually works on extraction from HTML pages. So if they change their layout or the way they represent data in that HTML page, then the web scraping is not going to work anymore. So there are a lot of caveats around that, and then also it's also sometimes it's also not legal. We are again going to cover this later on. A more feasible approach is like using online APIs. This is the more legal way of doing things. Twitter, Wegman, Facebook, Google, etc. All of these companies actually provide their APIs. Even governments provide their APIs. So APIs is something that, let's say Google wants to provide its data, then it's going to build some kind of system that abstracts or hides all the implementation on their side. They're going to provide you that the request and response for APIs, and then you're going to be that's all that's going to be exposed. So let's say for Twitter, it's something like you want tweets. So what is the time range that you want the tweets for? Maybe March to April. What is the location that you want the tweets for? Maybe United States. So all of this gets filled in the request, and in the response, you are going to get all the tweets for that kind of a request. And then you also have the option of offline data sets, Kaggle, KD nuggets, etc., etc. Again, these are not exactly, as the name says, these are offline data sets. So these are not live, but definitely these can be used for building your initial model. So if I want to train my model on past data that's maybe on data that's for a time range of 2000 to 2015, then it actually makes sense to use the existing data sets. There's no need to query APIs because API calls are expensive. So this is the third option. So yeah, these are the different techniques that can be used for web scraping. And then, introducing one of these side projects that I was working on with some students that are working. Like this was an academic project, and I was kind of helping folks out. Just a brief introduction. So in this project, what we tried to do was try to measure the number of cases in the United States, how that is fluctuating, how that's increasing or decreasing over time, and then try to compare it to Twitter sentiment around COVID-19. So we take a look at the tweets for related to COVID-19 for United States over the past months, and we also take a look at how the cases are increasing or decreasing or maybe staying flat over that period of time, and try to see if there is any correlation between these two. The ideal expectation here is that if the cases increase, then there's going to be a drop in COVID-related tweet sentiment. And then just an example how we used, so we use two of the techniques mentioned here, web scraping and online APIs. So for extracting the actual cases, we use web scraping. Worldometer is one of the websites that actually showcases the number of cases that are each day in the United States and in different states. You can see the table on the right, like in New York, for a given day, the table looks like that. The total cases, the new cases for that day, the total deaths, etc., etc. So we built a web scraping model around this and extracted all this data daily. The challenges around this, as I talked earlier, the tables keep changing, the HTML page keeps changing. In this case, it's not illegal since we used it anyway, so it's not illegal. But in a lot of cases, it's possible that it's not legal, and this is not a very scalable approach. But since the data here is very fixed, it's just one table that we're extracting daily, so it makes sense to just write a simple script to extract this kind of data. But for Twitter data, it's like we are collecting millions and millions of tweets. Like millions of people are tweeting in the United States about Twitter. So in this case, we can't. It's also not legal. And I think I'm not sure about this, but as far as I can recollect, you need to have Twitter's permission. You need to have a Twitter developer account to actually get that data and scrape that. So web scraping is not perfectly. I wouldn't recommend web scraping in this case. So we use Twitter's API for data collection. Again, as I said, there's a certain request that you need to provide them. So on the right, Twitter. So starting off, Twitter has a lot of APIs. We use the search API, but they have a whole bunch of APIs. On the left, you can see like These are all their get post APIs. Won't be diving too much into this, but just a short summary. We use the search API because we are looking for tweets. What the search API is that if you go to Twitter, you search for some COVID tweets, then all the tweets that would be listed for that search query, those you're going to get through the search through the Twitter search API right now. And like on the right, you can see some of the parameters that you send in the search API request, um, like geocode, that is the location that you're interested in, the language, the locale, again, that's a variant of the language, the count of tweets, etc., etc. So again, this is to use the Twitter API, you need to have a Twitter developer account. And there are limitations around this, that if you get a standard developer account, Twitter is going to limit that you can only collect X tweets per 5 hours or something. You can only collect 1,000 to 2,000 tweets every 2 or 3 hours. I don't remember the number exactly, but there is a limitation on that. So if you want to get all the data possible, you might have to pay for their services. So once you have the data, as I said, that data is not going to be something that you're directly going to visualize or analyze. You're going to be doing a lot of cleaning and pre-processing in that. Because that data might contain a lot of missing values. It's going to contain a lot of noisy data. So the next step that comes in the KDD process is actually data cleaning and pre-processing. And so this is the theoretical steps that are involved, and then we'll kind of try to understand this through, again, the side project. So some steps that are done here in data cleaning and pre-processing include cleaning in case of missing values. So if you have, for some tweets, let's say you have the location available, but for some tweets you don't have the location available, then maybe the best way to go here is that just exclude all the tweets that don't have location available, just to kind of have a uniform system. And also, maybe that parameter is more important to you. You can't build your model if some parameter is missing. So that's kind of a critical parameter for you. So it makes sense to actually exclude all the rows in your input that do not have that critical parameter. Then cleaning noisy data. Also, you can also remove discrepancy by performing some kind of data transformation. Another thing is that you can do here is normalization. Speaking briefly on normalization, normalization is actually far more important in machine learning. It's also important in data science, but it's way more important in machine learning, because what normalization means is that your parameters could be on an entirely different scale. So for example, let's take one, let me think of an example. Maybe the real estate example that we had previously. You're trying to buy a house, and then the prices could be, the house price could be in the range of millions, and then your other variables, for example, the quality of the quality of the house, that could be some float or a double value between 0 and 1. So now you don't want to, if you're fitting something like a linear regression model, you want to make sure that your house prices are normalized, because otherwise it could introduce a lot of problems, that one variable is in the magnitudes of millions and billions, and the other is a variable between 0 and 1. So to avoid any overweightage to certain parameters, it makes more sense to do normalization. So going quickly to our examples. So we collected the Twitter data, and then you can see at the size of the data set, initially we had like 100 million tweets. The size of that data set is about 1 TB. And then we performed some data cleaning, some data pre-processing, filtering our data set, and that dropped to about 3 GB. We only stored tweets that are of interest to us. And on the right is just an example of one of the Twitter APIs, like a get and a get request and a response for that. In the next slide, yeah. So and then yeah, in the next slide, so just some examples of what we did for our cleaning and pre-processing. So for Worldometer data, we dropped useless columns. So uh, if we go back to this slide, so a lot of these columns are actually meaningless. If you want to, we were only interested in new cases and how the cases were growing. So this also has like the tests being conducted or the deaths or and there's also actually columns to the right which are not very that we are not interested in. So we dropped all of those columns. And besides that, there wasn't too much of cleaning to do in the Worldometer data. But in case of Twitter data, converting the latitude, longitude to the state. So as I said, so our model tried to do this on a state basis. So basically, let's say in California, how many cases we are growing, how many cases are going up, and how many tweets have positive sentiment. So we try to do a comparison. Another model of us, like one comparison was based on an entire US base. One of the comparisons was on a US level, and the other was at a state level, like each individual states. So converting latitude and longitude to states, that's basically the Twitter API will return latitude and longitude for tweets. So if you want to map a certain tweet to a particular state, you need to convert that and have to have some logic around that. So transforming values, this is again one of the pre-processing steps. Then removing missing values. And again, so the Twitter text contains a whole bunch of noise that we can remove. So this is another example what we can do for a tweet. So on the left you can see the original tweet, and then on the right you can see the pre-processed tweet. So some of the things that we do is like converting all the tweets to lowercase just to have uniformity so that we can train it later on. And then you need to have as uniform data as possible. And then remove URL addresses. When you're analyzing sentiment over Twitter data, there's no point in actually analyzing URLs. So remove all this bunch of noise, URL address, Unicode, removing stop words. So stop words is something like that doesn't add too much when you try to analyze sentiment. For example, and because prepositions and stuff like that. So there are different libraries available for removing stop words. One of them I think is the NLTK stop word library. So we use that to remove stop words, remove hashtags. So yeah, this is like a brief overview of the pre-processing that goes into cleaning tweets in our case. And then this keeps changing depending on the data that you're encountering. If you're analyzing maybe Google search results, your techniques are going to be different. Maybe if you're analyzing YouTube search results, it's going to be different. So yeah, this is a brief overview of, and then eventually once we've done all the pre-processing that we can, once we've reduced our data set size, and once we have all the meaningful data that we want, once we are sure that we are ready for data mining or to start the process of actually extracting information from our data set, then we come to the data mining steps. And then we actually, this is a very critical step because now we need to choose the functions that will help us determining or extracting, that will help us extracting meaningful information from our data. So there could be a whole bunch of functions that we could use. That we could do aggregation, we could do clustering, we could do opinion mining. Our particular use case for the project is sentiment analysis. So that's an example of opinion mining. We are trying to mine over this whole Twitter data that we have collected. We're trying to mine the opinion of people, how that's changing over time. But there could be different analysis, like there could be aggregation. We've also done some kind of aggregation I'll talk about it later on, but these are like the different functions. You could aggregate the number of tweets that come from a particular state. You could aggregate, you could maybe cluster the groups of people. Giving examples of these, what aggregation an example of aggregation would be, we could aggregate the number of tweets that are coming from California. We could aggregate the number of tweets that are coming from maybe based on the gender, like how many males are tweeting, how many females are tweeting. And this actually helps provide a lot of important insights. So if thinking it from a company perspective, if I understand that, okay, my audience is let's say I have mainly my audience age group is maybe over 40, then I'm going to be suggesting, or I'm going to be building my models such that they are better suited for that age group. So aggregation and clustering are like one of the more important, one of the most common transformation functions, but these are also at the same time very impactful, and especially from company use case perspective. So in our case, as I said, we did opinion mining. Just taking a quick look at the time again. Okay, 45 minutes. So I think we are halfway through. So one of the so we did opinion mining, and these are the different algorithms that we actually use. I won't be diving too much into the details of this because we have a lot to cover, and expanding on these algorithms could be an entire talk in itself. But text blob is like one of the one of the simplistic algorithms. It's like the linear regression or the naive Bayes of sentiment analysis. Like I say linear regression and naive Bayes because like these are the first two algorithms that you learn in machine learning. So text blob is one of the first algorithms in and most simplistic algorithms in sentiment analysis. And then Vader and Affine are lexical analysis, lexicon-based algorithms. So lexicon meaning like these try to focus on certain words. So let's say I give you a tweet. Now they'll try to extract. They have their own library in which they have different words and they have different meanings for those words. Basically, they know they have a library which says that some positive adjective is actually a good word, like best is a good word, and you can think of it. So they have positive adjectives, negative adjectives, and they have an understanding in their dictionary that okay, this word means positive, this word means negative. So they use their own created dictionary and try to analyze these different lexicons in the text, and then try to aggregate the total score. This is a very simplistic view, but they based on the individual scores of these lexicons, they'll aggregate the scores and then try to predict that okay, if the total score is above a certain threshold, then it's probably a positive sentence. If the score is below a certain threshold, it's a negative sentence. And then similarly, if it lies between maybe some threshold, then it's a neutral sentence. And then ensemble is something that combines all of these models. On the right, this is just to give an insight on already existing models right now for sentiment analysis. Like IBM has its own Watson, that IBM Watson API that they have trained their own model for sentiment analysis. We didn't use this, but I just wanted to leave this out here because just so that people know that this is available. I think also Facebook has its own sentiment analysis model that you can use through an API. I don't take my word on that, but definitely IBM Watson has its model, and it's pretty good. If you can see that, if you see, it actually beats all of these Vader and text blob. So yeah, I mean, it's a little misleading to just look at the 565 number, correct, predicted, positive, but you need to actually add both of those to get an idea, like correctly positive predicted and correctly negative predicted. So if you add the two, then you can see that IBM Watson is actually better. And then again, this is not on our dataset. This is an online study. If we share the slides, then I'll probably post a link to this. Okay, and then once we have implemented our models, then for the final step, actually, This is the most important step when you actually visualize data and start understanding the results, what it actually means, so what all of your data actually means. And there are a whole lot of tools for data visualizations, Jupyter Notebook, Tableau, etc. We'll be having a demo on Jupyter Notebook later on. But this is the most important step, that you start, you actually look back on whether all of your data analysis made sense, and whether you're gonna. It's very possible that when you reach to this step, it's very possible to find that there is no meaningful information to be extracted from your data set, and this happens this happens more than you can think. I mean, it's not that okay, you build a model and now you're expecting that, okay, I'm going to see results and data sentiment of tweets is related to Twitter data. No, it doesn't happen like that. A lot of the times you're going to find that the data doesn't make sense, but a lot of the times it does. So using these tools these are some of the tools that you can use to actually visualize your data there. As I was talking before, how many what percentage of my audience is male or female, what percentage of my audience is above 40, what percent of my audience is below 40. So all of this meaningful information gets extracted in the stage of knowledge representation. So in our case, we visualized. So this is one of the first examples of how we visualize data. And in our case, we on the left you can see the actual cases. Like I said, we try to do this on a state level and on a US level. So this is our aggregation function. Here we are just comparing the number of cases in different states. So if on the left, if you see if a state is darker, then actually the left is actually you can ignore the tweets per state index, but it's actually the cases. The left is the cases, the right is the tweets. There is the index is not correctly labeled, but the darker a state is, the more the number of cases in that state. The lighter a state is, the lesser the number of cases in that state. On the right, you can see similar thing. But for tweets, the number of tweets in that state is, if it's darker, more the number of tweets. If it's lighter, the number of tweets is less. So if you see, then there's a strong correlation between these two graphs. On the west, we have California. I think I should have named the states, but I mean, this is what we have right now. But on the leftmost side, you have California, which has and this data is, again, this project was done maybe I think 2 or 3 weeks back, so this data is not fresh, but 2 or 3 weeks back, on the left, that is the west, California is one of the states that has a lot of tweets and also a lot of cases. Similarly, on the right, on the east, you have New York, which is the darkest for tweets. For tweets, it's not as dark, but still there's a strong correlation between those two. And if you try to observe the entire graph, you'll see that there's a good correlation between the actual COVID cases and the total number of tweets in those states. There are, of course, some exceptions. So Louisiana is an exception. Again, I know most of the audience would not know, but it's so it's actually one of this. If you go to the V-shaped state at the bottom is actually Texas. That has a good correlation, but just to the right of that state is Louisiana. To the right of the V-shaped state, if you look at Louisiana, there's not a direct correlation there because it has high number of cases, but it has fewer number of tweets. So there are a few outliers, but generally there's a good correlation here. So this is one of the transformation functions here, aggregation. Then moving on to this graph where we compare the number of daily cases with the sentiment. So yeah, on the blue line is actually the sentiment, and the other line is the number of daily cases in United States. So this is for United States. Now we've moved beyond the states logic. Now this is on an entire country level. So the number of states in you can see in March was not very high. Again, just a reminder that blue line is for tweets, the other line is for um, the number of cases. So initially there wasn't too many cases in March, but I think in around end of March the number of cases started spiking. So when there were not a lot of cases, the sentiment was it was there was a point when it was actually above zero. So that's actually a positive sentiment. So probably I mean, this is just one of the explanations. We try to explain this graph as in one of the ways that we can. This is not the only explanation, or this is not the correct explanation, but one of the explanations is that there were not many cases initially, so people were thinking that maybe the number of maybe United States is never going to see an increase in cases, so that the sentiment was actually positive. But as I said, towards mid March, or actually at the end of March, there was a sharp spike in the number of cases. The number of cases increased sharply from maybe 1,000 or 500 per day to 25 to 30,000 per day. And there you can see that suddenly there's a sharp downturn of the sentiment. So that's kind of a realization that uh, things are not going well, and then the sentiment starts to drop. And then towards the end of March and towards the beginning of April, the curve started flattening for United States, and I know that recently again we are seeing spikes in the United States cases, but this data, as I said, it's for the past. So for around April and May, the number of active cases in United States that started flattening out, and there it stopped increasing. Like you can see that number of active cases became constant at 25,000 range, around 25 to 30,000 range, and then you see gradually the sentiment also starts increasing. So yeah, this is one of our visualizations of this data set, and we found it very interesting to possibly explain this graph in this way. That there are again, I said you could have an explanation of your own, but this is more like a research project. So um, yeah, we found this very interesting. I think there's one more there was one more visualization. This is for number of cases versus the total number of tweets. So again, the same graph. Initially, the number of cases is pretty low, then it spikes suddenly, then it becomes constant. This is the number of active cases, just again to remind you. So again, and the other graph in this case is the other plot in this case is actually the number of tweets in that time frame, number of daily tweets. So you can see that initially, again, this is just our explanation of the graph. So how we explain this graph is that initially the number of tweets started growing because there was a lot of hype that not hype is not the right word, but there was a lot of curiosity, and a lot of people were talking about coronavirus. So there were a lot of tweets initially, and you can see that there are some sharp spikes in the number of tweets. Then it almost became constant around, like if you see the beginning of March. But as the number of cases increased suddenly, again there was a huge spike in the number of tweets. So yeah, that's the middle portion. And then towards the end again, as the number of active cases started flattening out, the number of tweets also started flattening out, and it became constant again. So yeah, these are some interesting visualizations, and just a use case of how data science gets used in day-to-day life, and how we can build models around something that we are saying, something that we are facing, something that's very essential and that become very crucial at this point in time. We can find meaningful information using data mining techniques. And we just I think it's about 1 hour, and I think at this point I'll hand it off to Sampath. But I hope that this gave some insights and some meaningful information about data science to the folks online. Over to you, Sampath. I think we'd like to also switch screens at this point.
Thanks, Gautam. So I have started my screen sharing. Let me know if it's visible.
It's visible now.
Okay. So you all might have got an idea as to why knowing about machine learning is so necessary. So before we jump to the libraries or the frameworks that we can use to implement machine learning algorithms, let us quickly summarize the different types or approaches in which a machine can learn. So over here in the slide, we can see that the different types of machine learning approaches. There is supervised learning, unsupervised learning, and reinforcement learning. So to give an overview, I won't be covering much in detail because yesterday as well as most of the part Gautam has already covered. So just for an overview, like in supervised learning, we know what the output is going to be, and from that training data, like based on the history data, we are training our model. And in case of unsupervised data, we don't have any kind of supervisor in unsupervised learning. We just have the training data, that is the X parameter, and we are going to find the similar features, and we usually cluster them, group the different data points. And the other approach is reinforcement learning. Reinforcement learning, you can consider like we introduce an agent to an environment and it learns based on the penalty and the reward it is getting. Like an example you can consider as a self-driving cars. So in this slide we have just written a brief about the different problems, that is regression, classification, and clustering. So in regression, we usually try to predict that the output of a that we are trying to predict, it is a continuous variable. So like the stock prices or the real estate prices, we are trying to predict the continuous output. In case of classification, the output that we are trying to identify, that we are trying to predict, it is going to be discrete, that is it would be labeled whether a email is spam or not. Similarly, in case of clustering, we usually group the different objects. We create clusters. We don't know about the output and we don't know much about the data. Just by observing the data, like we see the similar features and we group things. You can consider like based on the data, like number of people, data about the people. We can create different groups based on the ages, and we can, like suppose I am having an e-commerce website and I'm having a new product related to toys. So I would be aiming it to the age groups which are in the I would be aiming it to the customers which are in the age groups of 30, above 30, who are parents who would be buying the toys. So in order to show the ads and promote things to the right customer, I can make use of clustering to group things. So let us see from what all libraries we have in order to implement the ML algorithms, and which helps us to implement things in machine learning. So from yesterday, you all might have attended a number of sessions where algorithms in machine learning as well as deep learning might have been covered. So whenever we start exploring things, our main challenge of it would be like how we will be implementing the concepts that we are learning. So actually, from the implementation point, it's a relief for us. We already have a large number of libraries. Like at least in Python, we have a large number of libraries which have implemented the algorithms, and we don't need to write the entire code from scratch. So I have listed few of the libraries which are most commonly used. These are not the entire set of libraries. There are large number of libraries that are available over the internet. These are usually most commonly used, and you can even start like for exploration purpose. So the first three libraries that I have written down, it is related to the data processing and visualization. So to give a brief overview about each of them, Pandas. So Pandas is a library which actually helps us to extract the data and do reprocessing over it. So usually we have the data in the backend in either database tables or in files. So Pandas, it provides us a easy interface, like just a simple command like read underscore CSV to read the CSV files, and read underscore SQL to read the database tables. We just need to provide the table name and the database connection. That's it, and it would get us the output in a data structure named as data frame, which is similar to a table itself, and we can do a large number of column or row wise computation over the data. Similarly, we have NumPy. NumPy is a library which helps us to define multidimensional arrays. Usually, in the background, while we are training a machine learning model, a lot of mathematical computation happens. A lot of matrix multiplication happens. So NumPy library, it helps us with that. It helps us to do matrix multiplication or mathematical computation, I can say, in in a efficient manner. So for data processing and data extraction, we can use pandas numpy. So then we have matplotlib or seaborn, and there are there are many other libraries like bokeh, dash, which helps us for visualization. So using matplotlib and seaborn, we can plot different figures, plots like violin plot, line chart, and other things, pie chart. All can be achieved using matplotlib and seaborn. And in order to implement machine learning algorithms, we have one famous library named as scikit-learn. So most of the machine learning requirements, it has been covered in this scikit-learn package, scikit-learn library. We don't have to code much. We don't need to reinvent the wheel. We don't need to write the code from scratch. A lot of present inbuilt in scikit-learn libraries. And this is not just it. There are other libraries like XGBoost, which is even more for stacked models. We usually have random for different algorithms like stacked models, random forest algorithm, which is part of an ensemble model. So we have XGBoost library, which is much more efficient than scikit-learn, but most of the requirements are already covered by scikit-learn. So just to show you how easy it is to implement a machine learning model, let me take you to the scikit-learn library. Scikit-learn website. So this is the main page of Scikit-learn, and in the homepage itself, I can see like how well it is documented. It is showing me three different problems, not just three. There are multiple problems like for dimensionality reduction, pre-processing, for classification, regression, clustering. So all the different algorithms, they have been separated under the labels like for which we can use that. So if I open any algorithm, I can see like how easy it is to implement that algorithm. So here we are seeing random forest classifier. So in the backend, what random forest does is it builds a large number of decision trees. Decision trees is more like we are building a tree, and each at each node we are making some kind of we are performing some kind of conditions, and we are going to the leaf node where the actual output class can be predicted. So at each step in a decision tree, we are trying to make a decision, and we are coming to the end. There is It's more like a rule based system only. So in random forest classifier, we are building a large number of decision trees, and we are generalizing the decision tree result. So, but we don't have to go through the complete understanding of how you would be coding the entire thing. You can just create a object of the class, and you can provide how many trees you want to be considered for the training purpose. And just calling the fit function would do the thing. Like it would access my training data and y is the label that I have. And I have already done the fitting on the data, and just using clf.predict, I can predict the new data points. To show this more in detail, I have created one notebook as well. So this is Jupyter Notebook. It actually usually when we write code, we create dots like in C and or C++, we create .c or .cpp file. Similarly, in Python, we create .py file. So Jupyter Notebook is also a similar environment where we can. It is an environment which helps us to execute Python codes or R code as well, and we have cells over here. Like we don't need to run the entire .py file. We can just print something or write commands and see how things are working over here. Similarly, we can initialize things, and we can see what the value has is present. Like you don't need to write the entire code. You can just experiment things over here, and you can see like how things are working. So usually the training, the modeling for modeling things, they usually happen in a notebook like Jupyter Notebook or Google Colab. And after things are in place over here, once we have trained our model, we usually deploy it in some kind of API. That is when the actual .py file comes into picture. For visualization and for other training for data processing, we usually use Jupyter notebooks. So just to give an idea as to how easy it is to implement a algorithm. So over here I'm taking Boston data set. So the target that I'm going to predict, it is the prices of real estate I'm using an inbuilt dataset only that is present in sklearn. And for implementing the algorithm, I have imported one random forest regressor library. And in this code block, I'm loading the data that is using load underscore Boston, and I can see like what all data is present. Like these are the features that is being used to predict the house prices, and my output target variable, it would be the price value of the property. So in X and Y, I have stored the training X and Y. It has it's the complete data set. Y is the target variable, and X are the features that I'm going to use in order to predict Y. So as even Gautam has covered, like the normalization process that we do in almost of the algorithms, which involves updating the weights or which involves distance metrics, we perform the standardization or normalization process. So in order to do that, like standardization and normalization, it is done to bring all the features, all the columns that we have in the data in the same scale. So you can see like how easy it is to transform it, like to standardize the complete data set. So if I see X, it would be in the range of, it would be having a mean of 0 and a no, and a standard deviation of 1. So once I bring it to the same scale, I'm doing the train and test split. So whenever we are going to train a model, we never train it on the complete data. Like we take a portion of the complete data set as a trained data, and the rest of the data that we are going to have, we are going to use as a test data to see how my model is working on unseen data. So basically, I'm doing a split in the ratio of 20%. 80% would be considered for train, and the rest 20% would be considered for testing purpose. And if you see in this block, the entire model training has been done. So I have created an object of random forest regressor class, that is CLF, and I'm calling the fit method. And I am passing X and Y values, the train values. I'm not exposing the test values, I'm just showing it the X train and Y train values. And based on that, it has learned, and I'm passing the X test values to see what all it is doing the prediction. Like I'm passing the test values and seeing what all Y values I'm predicting. And using matplotlib, I have done a plot of the prices, like what is the actual price. So in the x-axis you can see the actual prices, and in the y-axis you can see what my model has predicted. So if you see like when the price, the scales are not perfect, it would be more like 10 lakhs or something. But for an understanding, you can say this, like when the price was 10, the predicted price is also 10. Similarly, when it was 20, the predicted price is also 20. But there are errors, like if you see when my price was in the range of 20 to 30, like around 25, 28, you can see that my model has predicted around 40. So these are some errors that has been done with by my model. But you can see like it is giving me a 45-degree line, showing me how well the things have been predicted. So just to train a model, it is that simple. You just create an object, and you call the fit and the predict method. That's it. But this is just for an entry level. You need to know like how things are working in the background, and it is not just this. We have a number of features, like the number of estimators. There is a concept like overfitting and underfitting. Like it happens that there can be a possibility that that my model is just overfitting the training data, and when I'm exposing new data, it may be a case that it is not working at all. It is showing some garbage value. So there are a lot of features that need to be considered while training a model, like underfitting, overfitting. So we have regularization, we have the number of estimators in random forest. So these are the hyper parameters. We have to change, we have to experiment and see what works best for in our case. So this was one of the machine learning algorithms. Most probably like algorithms like random forest and all are used. So this was one of the demo related to random forest. The other library that I have covered is deep learning. So in deep learning, you might have seen in yesterday's session, that we were having neural networks and multi-layer perceptrons and everything. So you might be thinking like how complicated it would be to code the entire neural structure. You might have to like build the graph. You might have to define the activation units, input, how to connect the graph and all. It is like from the coding point, if you think like from the basic, it is quite complicated. but we have TensorFlow and Keras libraries, which makes the thing easy for us. So I've even added a simple code related to Keras. So here what I'm doing is I'm trying to predict I'm doing digit class. This is more like a digit classifier example. So this is one of the image, and this is the label which has been stored for this image. So like, just to start from the beginning, I've loaded the data from Keras itself. That is the MNIST data. It is most common. It is one of the commonly used. Like at the beginner level, everyone does work on this MNIST data to learn. So I have loaded it using this command, and like train test split, like as I said in the previous ML demo, like we are doing the train and test split, and the size you can see, size of the training data set you can see over here. That is, we have around 60,000 data points, and each data point, it is 28 cross 28. So it means that if you see this image, this is one of the data point, and it has around 28 cross 28 pixels. That is around 784 something pixels are present in this. And the image I have, like, we are going to feed it in the numerical format to the network. We are not going to feed like, we have to do some kind of processing of the data that we have. So I'm not going to feed the entire thing to the network, like the image itself. I'm going to convert it into some representation in a numerical format. So the X-train and Y-train values, it is 28 cross 28 matrix, which has the RGB scale from 0 to 255 at each pixel. So this might be 0, this might be 0, this might be something 255 or something. So this is the numeric representation is being stored in X-test and X-train. Similarly, the labels that I have, like 0, this is 0. After converting it into X-train, the label Y-train, what it is, it has been provided to the model in Y-train. This is just the splitting of X-train and Y-train, and the representation of as to what the data is. So I have done the plot of the Y-train value, like first value at index 1, the data point 1, and like it is 0. And plotting X-train, this is the image that I am getting. Now, if you might recollect, like from yesterday's section, you might have seen the neural network. Like, we were having multiple layers, multiple activation units, multiple neurons in the layers, and each were having a different activation unit. So the complete network, it has been defined in this part. First of all, I am doing the normalization, as I said, like bringing it all to the same scale. I did the normalization, created X-train and X-test, and then I'm defining the network. I'm just adding different layers. This is it. I'm flattening the network. I'm creating a feed forward network. I'm adding dense layer having 128 units, and I'm defining what all activation unit is to be considered. And for classification, what we are doing is we are having digits from 0 to 9. So I'm using an algorithm named as softmax, which is going to give me a probability value for each target value. Like from 0 to 9, it is going to give me a probability value. And the highest probability, like if the probability for a data point, if my probability of 1 is the highest, then I would be classifying that data point as 1. So that softmax would be doing the work. And in this part, I'm just doing like what all optimizer need to be considered, and what loss measurement I need to consider in order to minimize it, and what is the metrics. I'm using accuracy over here. So like the entire diagram that you might have seen in yesterday's session, it has been defined in this piece of code. That's it. And over here we are doing the we are calling the fit method, and we are saying like we are defining the epochs, that is how many time it has to iterate through the data set, and it has to update the weights. So in each epoch the learning is happening, and we can see the training and test score over here. After we have done the fitting, like model fit has been done, we are evaluating the metrics, and we can see the loss score and the accuracy score. We can see that almost the model, it is 97% accurate, and we are doing the evaluation based on the test data. So now we have done the training of the model, we have defined the model, and we have done the training. Now comes the main part, like how do we deploy it? Like, do we need visually in the industry level, we never train the model at the runtime. It happens like the training part is done prior, before the application is developed. We save the model. So this command, it is saving my model in my disk. This would be saved, and this is the command through which I can load the model, and I can use an API, create an API which my web application can hit and get the output. So this is that simple. I'm just loading the network and the weights, and I'm saving the network and the weights. I'm loading it just by these two commands. I can do the deployment as well. So for the testing purpose, like I've taken the y test value, like what I'm seeing, like what is present in in y test, what is present, what is the label at 100 index. So I can see like it is 6, and I have plotted x test value as well. This is just for representation to see whether actually my model is doing the right prediction or not. So I can say that this is the image that is going to the model, and I'll pass the index of that index of that data point, and I can see the prediction, and I can see what the value is being predicted. So from an image, like by this small notebook itself, we have built a model which can do classification over the which can classify digits from the data, which can learn to classify digits from the images. So this is how simple it is to implement a neural network algorithm using TensorFlow and Keras. So you don't need to write everything from scratch. Everything is already present in form of libraries. You just need to know how to apply it. That's it. And from the development environment, the notebook that I was showing, it was Jupyter notebook. And similarly, like the main problem that we have is related to the computation. We don't have much computation power at our our PCs usually don't have much of a computation power. So there is one more node. Suppose if your personal laptop, it doesn't have much of a computation power to do some kind of data processing or to run some model training algorithm, so you can use Google Colab as well. It is hosted over the cloud, and they provide their own resources for training purposes. So for training the model, data processing, you can use any of these notebooks. And for the deployment purpose, we usually create a web API. So as we saw that we were saving the model to the disk, we can use that model and we can create an API around it. And just we need to we save the model over to the disk and load it in our API and call the predict method to get the output. So we usually have Flask and Django APIs in Python. So from the implementation point, we saw that like how easy it was to implement an algorithm. But when we come to the come at an industry level, like things are not that easy. Like we don't just take some algorithm like random forest and build it. And it isn't like just we use pandas and read the entire table or read the entire files that we have. Suppose for example, at the industry level, we have a lot of data, like data, like a minimum of 10 GB or 20 GB of data we have. Like, we usually have a large amount of data. So in order to process it, we can't load the entire data to our main memory. We usually, what we do is we make use of different libraries like Dask, or we can write our own. Like we can divide the data frame or the files into chunks, and we can keep bringing parts of the data into a main memory for training or for data cleaning purpose or data pre-processing purpose. So like for an entry level, you can explore pandas, NumPy, Matplotlib, but at the industrial level, you need to have other, you would be learning a lot of other libraries, or you might be using the computer architecture concepts, and you might have to build your own design as to how to process the data, or how to bring the things into the main memory. Like you need to have an understanding about CPU, GPUs as well. And from the visualization, like we saw that we need to, when we train our models, it shouldn't be a black box. We need to give a proper representation as to what is happening at the back end, like what the results are and how those results are coming. So an end-to-end understanding of the model is necessary, as well as showing the results like in the in a proper visualization to the end users. Like whenever you're not going to write, you're not going to develop a feature. The requirements are going to be coming from the business side. So they would be giving you a problem. You have to understand like what the data you can use, and you have to show the visualization of those data, and you can show how you can implement different algorithms around it to get more better features out of those data. So the main thing, it's not like just fitting the model and all. The main part that goes into a machine learning or data science project is data pre-processing. So if you see the initial two steps, that is preparing the data or engineering features, this is the two. Even the studies have found out that a data scientist, he almost spends 50 to 80% of his time preparing the data and doing the feature engineering. So as I said, like, you are not going to discover feature in a company or something. You are going to just get the business requirement. You have to ask the question to the domain experts, with the business people, to understand how it could be done in a manual way, and then you approach that solution and try to automate it. You try to explore like what all data you have, and how you can how which data can be used in a more efficient manner, like which all features are more correlated with my output. And you, like, almost 80% of your time you have to spend on preparing the data. It is more like if you feed garbage data, if you're trying to predict real estate data, and there is some table that you have got access to, it has around 200 300 columns, and you just take those complete data and you're going to train your model, and you are going to show the result. It would be more like you're just feeding garbage to the model and you would be getting garbage out of it. So you have to make sure that you're preparing the right set of data and you're engineering it in a proper manner. Once you take the data, you train it, and once you get some good accuracy or performance metrics, you deploy the model on the on the server or something, and it is visible to the end customer. But the catch is, like, our work is not done over here. Once it goes into the production, we have to keep monitoring the model as to how the trends are changing. We have to keep checking as to how frequently we would have to train the data. If you consider the stock price, like if suppose I have built some model for predicting the stock prices, or have built some model to predict the sales of a company. But if you see in the last 3 months itself, like, due to the current situation, like, the entire market has changed. So you can't rely on the history data itself. You would have to retrain your model, and you need to keep implementing new things. Like, you would have to re-engineer the features. You would have to revisit the entire flow again. So it's not like you just train a model and it's done. You have to keep monitoring the model, and you need to have some performance metric which would trigger, like, if I'm having some threshold or for some performance metric, I have some threshold. Whenever that threshold is met, like, I would have to again revisit the entire flow and have to retrain the model. So this is how it works, how an entire engineering, data science or ML project engineering works. You prepare the data, train the data, deploy, and you keep on remonitoring it. So for some more industry insights, I would be handing over the session to Sami. He would be covering from this side onwards. Thanks a lot for giving your time.
Hello, am I audible?
Yes.
Okay, I'll be sharing my screen now. I think there's some issue with my browser at this point of time.
Maybe someone else can present if it doesn't work.
Yeah. Gautam, I think you should share the screen, and I'll just ask you to move to the next
Okay.
slide whenever I want. Yeah.
Okay.
Yeah. So, yeah, I hope I'm audible. So, basically, yeah, I'll be talking about industry insights because Sampath and Gautam have already covered a lot about code and implementation and everything else. So, I mean, the first point is obviously it's not always necessary to reinvent the wheel. And what do I mean by that? So, for example, as Sampath and Gautam showed, that there are a lot of libraries, APIs, and services that you can use to implement and use machine learning models in your code, in your application, without having to understand the underlying details of the implementation. But obviously, it's always important to balance between understanding the model versus using an API. And it also depends on your objective. I mean, if you are, like, for example, if you're a professional who wants to deliver something in a given timeline, then obviously you can't implement an image processing model in 1 week and get the results and expect to get the results like a Google classifier or a Google's model would do. So obviously it's always important to maintain a healthy balance. But then again, if your aim or objective is to learn and understand the implementation details, maybe as a student you want to apply for the roles of, let's say, a machine learning engineer or a junior data scientist right after your graduation, then obviously in that case it becomes really important to understand what's exactly happening under the hood and see how it works and implement and play around with algorithms and parameters and everything else. And well, and also in a like the last point about the product managers, ML development, and selection of features. Well, in that case, in an actual industrial scenario, like in a college project, I mean, we generally think about features, think about data. We come up with a project. Let's say like Gautam showed the Twitter case. Like we decide that okay, I need to analyze the COVID case through tweets maybe, or through Facebook posts maybe, or it could be anything else. But in a real life scenario, you can't just randomly pick a project, or you can't just come up randomly with a set of features. Okay, these are the 5 features that I need to work on. So what actually happens is you have to really closely work with other people involved in the process, other software engineers, maybe product managers, data analysts, and these are the people who are the actual decision makers who decide what is the expected user behavior and what we want out of our users, and what is the behavior based on a lot of tracking mechanisms that I'll be covering in detail in the later slides. But the point of this is that you have to be really thoughtful about the features that you choose, the data that you choose, the kind of sampling that you do on your data, and you can't just randomly pick a data set, or randomly sample a data set, or randomly pick your set of features. So there are a lot of factors that go into this process when it comes to deploying or building ML models. There's a lot of planning phase, there's a lot of discussion phase, there's a lot of analysis phase, like the previous data of a particular group of customers, and what we want to achieve, and what are the results that are visible from the previous data sets. So these are the things and these are the challenges that you have to understand and you have to overcome and solve these problems. And only then you go about actually building or even thinking about building a machine learning model. And if you're going to do it, then how you're going to do it. Maybe do you have the bandwidth to re-implement a model in your team? What if you don't have a dedicated machine learning specific or data science team? Then how are you going to do it? Do you have the bandwidth, or are you just going to use the APIs? Obviously, using the APIs, it sounds good, but then it comes at a cost. Like, I mean it literally, like you have to pay whatever the services that you are using. You have to pay Google, you have to pay Amazon, and then these things become really, I mean, it's you can get a student account or something like that when you're building a college project. But when you talk about industry where you have like, let's say, more than 1 million active users, and if you want to use a particular image processing service, let's say, for example, or a classification service or a detection service, and if you have 1 million users and if you have just one picture per user, then you have to think about using the service. Even if you're using one API call per user, then it's about 1 million requests for 1 million users, and with each user uploading their own image. So these are some of the practical things and practical scenarios that you need to be very aware about before actually jumping into using APIs and there's a lot of comparisons that are done between, like for example, Amazon is providing, let's say, a similar API as compared to Google, and as compared to Microsoft Azure. Then you have to be very uh, thoughtful about how you're going to make those decisions, and it all boils down to your requirements, your bandwidth, your timeline, your budget, and a lot of other factors. Gautam, can you just move on to the next slide? Yeah, so this is about some popular choices for ML services. Like, for example, like AWS is obviously the most popular choice, be it machine learning or non-machine learning requirement. And there is Microsoft Azure, and there is Google Cloud as well. Now, the advantage of using these services is that they not only provide you with APIs that are software services, but they also provide you with a lot of infrastructure services as well. For example, one way to deploy an ML model would be to actually take a simple EC2 instance, an Elastic Cloud Compute instance from Amazon, and SSH into it and manually install Python and all your other dependencies, train your model and do stuff like that. But then it will be obviously much more cheaper. But then again, the problem with this approach is that your majority of your time will be spent on managing the resources, the deployment, and dealing with a lot of infrastructure issues and a lot of setup related things, as compared to actually working on your machine learning model, or actually training your data or analyzing the results. So obviously you need to think about these factors when choosing a service provider, and when thinking about deploying a service. But then other alternatives to using a simple EC2 instance could be a managed service. For example, AWS provides a lot of managed services for the deployment of your machine learning model, for monitoring of your machine learning models. For analyzing your data, representing your results in a graphical way. So obviously, these are some of the managed services that AWS provides, Azure provides, Google Cloud provides. But then again, it comes at a cost, and obviously you have to keep all the other factors in mind about how you're going to choose these services. And the benefits, again, of using these services, especially the software services or even the hardware services, is that AWS expertise in handling infrastructure. Or, for example, Google has a really strong machine learning environment, or a culture, or a strong team. So obviously, you're going to benefit from the expertise of Google or Amazon or Microsoft or any other service provider, without having to do a lot, just by making an API call or just by setting up your entire deployment pipeline or infrastructure at a click of a button. So obviously, it makes a lot of sense to use these services rather than reinventing the wheel. But then also, uh, as I said again, that it's important to keep the other factors in mind. Now, some of the services, for example, AWS Forecast is as one of the services that provides a lot of ready-made pre-trained models, which can be used by any organization for, let's say, predicting your sales based on your previous data. So they expect you to upload a certain data set, and they ask you to define what are the factors, what are the features of your data set. Maybe you can say, okay, this is a monthly data, and these were the sales, and these were the other factors, and then this was the location of the user who was actually buying this thing. So you can use these pre-trained models and just tweak the features according to your requirement, and use these services like AWS Forecast. For example, another service is something like a fraud detection. There's a lot of fraud detection that happens in online payments. Or there is AWS recognition, which is used for recognizing objects in an image, or something like celebrity detection. A lot of services, for example, don't allow you to upload pictures of celebrities on your profile. Facebook allows it, but a lot of services they don't. They want the users to upload their own pictures, especially if it's a picture-driven platform. So they want the users to upload their own pictures. So in that case, you need to filter that. Okay, you need to first identify that the user has uploaded a picture of, let's say, Amitabh Bachchan or Shah Rukh Khan or some other celebrity, and that identification process, if you do it on your end, then it's going to be very difficult, extremely difficult. But with something like Google or Amazon or Microsoft, they already have huge data sets, and they have already pre-trained models, optimized models that can identify whether a picture that has been sent to them through an API or uploaded on their console directly is of a celebrity or a non-celebrity. A simple use case. Or if a picture contains some kind of nudity, which we do not want the users to upload. So these are the things that these services provide, which we can definitely use to optimize and to build our applications in a much faster and efficient manner, given the fact that we have resources and bandwidth and budget, especially to use these services. So yeah, Gautam, you can move to the next slide. So programming languages for machine learning. So I'll be talking about this from students' point of view about how students, especially who are in college in the second year, third year, or final year, what should be their approach. And as Sampath and Gautam already gave examples in Python. So obviously, Python is definitely the most popular choice given the entire ecosystem and libraries it provides for data collection, parsing, training, etc. And rightly so, because using Python, Sampath gave you an example about how easy it is to train a model. You just have to call an API and you can just be done with training a model. You can just use a predict function and you can provide it with the data, and then it will predict the results for that particular data set. So it obviously makes a lot of sense, and not just in machine learning but generally in software engineering, to use a technology which already has a strong community, a strong support, because that technology is going to be very relatively easier to use. Because if you're stuck somewhere, you can just go to maybe Stack Overflow and post a question, and you can be very much sure that you'll be getting a response in maybe a couple of hours. But using some random technology has its own cons, that its ecosystem will not be that mature. It will not have as much support as you would want it to have, and you will end up getting frustrated a lot of times, especially if you have just starting out into machine learning or any technology. But again, having said that, as a student, I think that shouldn't be the case, that okay, I can't code in Python, I just know Java, so can I still use machine learning, or do I have to first go through the process of learning Python for a month or two, and only then I can use or start with machine learning? Then the answer is no. It's not really important to learn Python if your objective is that you need to implement algorithms, implement the models, and understand how it works. Then obviously it doesn't matter whether you use PHP, Python, JavaScript, Java, Node.js. It just doesn't matter, because finally it all boils down to your statistical models. It all boils down to the core logic that you're writing, as compared to, or as opposed to, the programming language that you use. But having said that, a lot of organizations use Python, and a lot of startups, in fact, use Python not only for prototyping but in production as well. And well, one of the main reasons, as I said, that the strong community support, when you're just started with building a machine learning model, when you're in the initial phase, there is a lot of trial and error and experimentation that goes on, and using a compiled language like C++ or C, or anything like Java, can be a really tedious process to make those changes, compile the language again and again, and there's a lot of overhead that comes with these programming languages. So therefore, a lot of mature organizations, what they do is they go for Python when it comes to prototyping, but then once they have decided on some basic set of features, that they use C++ or other compiled languages. So yeah, and also a lot of technologies use like Python, or there is a TensorFlow support for JavaScript as well. A lot of these libraries compose themselves through their APIs in JavaScript and Python respectively, but under the hood, if you read their implementation, it's going to be C++ or something, some low level language which will help them to optimize the performance. So yeah, this was for the programming languages for machine learning. Gautam, you can move to the, yeah, so this is the point that I would like to cover. So Gautam gave you a brief overview about using APIs versus scraping the data, and I'll just continue and reiterate on that. That a lot of students, including myself, back in college, we used to scrape the data, but and it can seem like an easier solution, because using an API initially would require you to have a developer account, get the API access token, and integrate it into your app. A lot of times the APIs are not free. You need to buy it, and a lot of other challenges. So a lot of people, what they do is they just so basically, what is data scraping or screen scraping? It is also known as screen scraping. What is it? Is that basically you just make an API request to a server, a simple GET request. So, for example, whenever I open Google.com, it's a simple GET request to the Google server, and Google responds it with HTML or the data that is required to display. So basically, there is something like backend rendering and front end rendering. So if it's a backend rendered app, then basically Google will respond you with a complete. They will prepare the entire HTML. They will contact with the database. They will use their application logic. Finally, they will generate some kind of view layer, which is HTML, and they will send it to the front end, that is your client. Now, in the case of browsers, the client is your browser, obviously, and browser is capable of understanding as well as rendering this HTML. So whenever you can just go to Google Chrome and you can go into your network tab and you can see what are the requests that this. You can just refresh your page and see what are the requests that this particular web page, be it Google, YouTube, Amazon, or anything else, is making, and what is the data that it is getting from the backend. Is it HTML or some kind of JSON or XML or something like that? So what happens in case of browsers is when it gets the HTML, it just renders it, because that's how browsers work. But with data scraping, we don't want to render the HTML. We just want to extract the important information that we want from that HTML. So let's say if there's this government's website that reiterating on the example that Gautam gave, like for example, if there's a Maharashtra government website which has some kind of COVID-19 cases in Maharashtra, and we want to take that data. So one simple approach would be to just make a GET request to it. Now, you can use Python, you can use a simple curl request to get the HTML, or you can use JavaScript, Node.js, whatever it is. I mean, as long as your programming language allows you to make a simple GET request, you can make that API request and you can get the HTML. Now, once you have the complete HTML for that particular page, all you have to do is just identify the important or distinguishing parameters in that HTML. For example, your table might have for example, your table syntax for HTML might have a particular unique ID. Now I know that if there are 3 tables on this page and I want the data from the table number 2, then I can either use something like regular expressions if you do not want to use any existing libraries, or Python, for example, comes up, or it provides you with a lot of useful libraries for scraping your data, like something like Beautiful Soup or Scrapy are some of the options that you can use to extract your important information from your entire HTML. So, but again, having said that, it is not legal in a lot of cases, it's not legal to scrape the data, make these hundreds and thousands of requests to a particular server without their permission. So generally, it should be avoided to fetch the data through scraping. But again, then you can try contacting the admin of the website and seek some kind of permission if you still want to, if there is no API available and if you still want the data. But generally, I do not recommend, or we do not recommend, that you should scrape, because you can land into a lot of legal issues. Because in a way, if let's say if you're trying to scrape a website, a simple small application from 5 AWS EC2 instances, then you can cause some kind of denial of service attack on that website, and that website unfortunately won't be accessible to the genuine users. So it can land you into a lot of trouble. So just be always very careful about doing anything like that. Better to use obviously standard APIs, Twitter, Instagram, etc. Almost everybody these days provides you with APIs for the public information or whatever information that you want. And yeah, and again, like Gautam said that apart from the legal implications, one of the problems with scraping is that if I just change the ID of my table, I won't be able to fetch the data. Because let's say if instead of 20 instead of 2 I replace it with 20, then you are just not going to get anything out of that HTML, because there won't be any table with the ID 2, because they replaced it with 20. So, and apart from that, a lot of sophisticated systems like Google and other companies, they block your scraping scripts. If you're continuously making, let's say, making 10 requests per second, then that's like 600 requests per minute. And if you're just continuously running that over hours, then Google or other services can literally block your addresses. So it's obviously not really helpful. So, and apart from APIs and scraping, governments and a lot of other organizations provide a lot of open data sets which can be easily used for different applications. Like there are medical data sets available. There are population related data, finance data. World Health Organization provides a lot of data. There's DBpedia, which provides you with a lot of important data from Wikipedia articles. And there is data provided by Indian government on data.gov.in, I guess. These are some of the data sets that are used. But then again, this is the data. This is the type of data that you want to use when you're building a general application, like analyzing Twitter or tweets based on a particular hashtag, let's say COVID-19 or a particular issue. But then again, how it works when we are actually working in a production environment. By production environment, I mean in an industry, is that in my company, for example, I'm not. It doesn't matter to me what Twitter data says, because for me, as an engineer, what our customers think is much more important than anything else. So companies generally, a lot of large scale companies, they have their own built-in tracking systems. So, for example, when you log in on a website, so they will have some kind of track event that they send. Okay, Samir has logged in from his Android phone. Okay, Sampath has logged in from his Google Chrome browser. Gautam has logged in from his iPhone app. So these are some of the built-in or not built-in, but companies build their custom tracking services to track user data, and it's just not limited to tracking based on platforms. It's just a simple example. You can build completely sophisticated systems and get a lot of user data and analyze them and build your machine learning models based on that. For example, a lot of companies send you promotional emails. Like a company might send you a promotional email, a promotional SMS, browser notification. Let's stick to three, an app notification. Let's say four things. So a user might sign into your application through any of these sources. Like you might send some promotional, like for example, Amazon. Whenever I visit a product, Amazon immediately after a few hours sends me an email sending key, you would like to buy it. So how does Amazon do that? So Amazon is continuously tracking what product did this particular person visit, and how much time did he spend on that product. Was he really interested in bought products, any similar products related to that in past? So these are some of the things. For example, if I buy a particular T-shirt, let's say, or if I buy a formal shirt, so Amazon knows that I'm more likely to buy a tie as compared to someone who's bought a T-shirt. Then for understanding or for suggesting these things to an actual end user, you need to continuously track. So wherever a user visits on your website, through a web app or through a mobile app or through a mobile browser, and what is the source? Is he visiting through an email? Is he visiting through a notification? Is he visiting through an SMS? So these are some of the things that are tracked. And even when you have logged in, uh, the entire user journey is tracked. What is the first thing that the user did when he landed on the website? Did he went to the home page, or did he went to the purchase page? Did he went to his cart, or did he went to his order history? What did he do? And when you see a particular pattern on a large number of users, then the product managers actually come up with different plans, how we can use this data to actually build ecosystems or build features around this data that will help us improve our business, or that will help us in providing a better user experience. Like for example, if you realize that whenever the user logs in, you're showing them some kind of promotional modal layer, and any kind of interruption layer is obviously very annoying for a user. And you realize that 70% users are more likely to drop off from your applications if you show them a promotional layer right after landing. So so this data is collected, and the entire user journey is decided, tracked continuously through the kind of buttons you click, through the kind of to the web pages that you visit, to the products that you view. In case of Amazon, it will be different obviously in case of YouTube or Google. Maybe in YouTube's case, it could be something like, what are the kind of videos are you watching? Is it a music video, or is it a comedy video, or are you watching over videos of a particular celebrity, or you're interested in programming or learning about machine learning? So maybe it will suggest you more videos on similar lines, or maybe related to that, something like that. Maybe you're watching scraping a lot, so maybe YouTube will try to recommend that maybe you're interested in building some kind of machine learning model. So it's a very complicated and sophisticated system that companies use to track user data and analyze this data through an entire pipeline and a process, and come up with features and insights based on that. So yes, so general development principles. So what actually happens on a production environment, and the difference between actually using machine learning models or any kind of software engineering on a college level, and actually using it at an industry level, where there is a decent amount of scale, not startups exactly, but
I think Samir went offline for some
yeah, yeah,
reason.
yeah. Gautam, am I audible now?
Yeah.
Hello.
Samir,
Yeah, you
just
can.
time. We have like maybe 10 minutes more, 5 or 10 minutes more. So we might
Yeah,
need
yeah, I'll just try to.
to. Yeah.
Yeah, I'll try to wrap it up quickly. Thank you for the reminder. You can just yeah. So basically, yeah. So general development principles. I'll just try to keep this short. Uh, so basically, what happens on a college project level is that we do not have a lot of data. So and things actually change at scale. A particular system might work completely fine on let's say 100 users, but when you go at scale, let's say a million users, then the problems can be completely different. So for example, your machine learning model might work for a college project, but it might completely fail and stop working when we talk about a million users, right? And what this happens is that a traditional simple client server architecture has its own limitations. Let's say you're just taking a simple AWS EC2 server and you're just hitting it with million requests, and with every request your model needs to have some kind of 5 second computation or something like that, or maybe it's an image processing model, so it might need a longer time. So what happens on scale or at an industrial level is that you need to have an understanding of a lot of technologies that are not necessarily machine learning related, but are really important if you want to deploy and build models on scale. For example, like I said, that a simple server architecture might not work in case of Google, Amazon, or even with a relatively smaller organization which has just a million users. So there are other technologies, like for example, pub subsystem. It's a simple publisher subscriber model. So something like that can be used. So what is a publisher subscriber model is that you can have something like a job queue, a messaging queue, where you can have a publisher, you can have a subscriber. The job of the publisher is to publish to that queue, and the job of the subscriber is to subscribe from that queue. Now, these publisher and subscribers can be anything. They can be different apps altogether, or let's for the sake of simplicity, we can say these are two different Python scripts. So what will happen is that, let's say I in my application I upload a picture, and I need to validate or identify or detect whether that picture uh, has some kind of nudity, or has some kind of or is it a celebrity picture or a non-celebrity picture. So I need to do that, and let's say I have a million users simultaneously connecting to my this particular service. So what I can do is that instead of just directly sending my image and my data to the machine learning model, what we can do is the publisher will fetch this data from the front end through the back end, and then after that it will publish it to your messaging queue, and your subscriber will continuously listen to the message queue and will fetch your job or task from that particular queue, and it will give it to the associated or related machine learning model. So in this case you won't choke, because your subscriber will only give or transfer these tasks to your actual model when it is available, when it is free. So obviously one of the drawbacks of this method is that your images won't be classified immediately, because it will take a couple of hours, and this generally happens in every app, because it takes at least a couple of hours to, whenever you upload an image, it takes a couple of hours to actually for it to go through the entire validation and every process. But then the best part about this is that you won't have to worry about choking your server. Obviously, there are other challenges, like even uploading million requests, or handling million requests at one point of time in your backend server will have to be handled smartly, maybe through an elastic load balancer on AWS or something like that. But then again, I'm just trying to focus this on how it would look when we talk about deploying ML models on scale. And there are I'll just try to keep it short. Then again, I'd like to talk about A/B experiments. So whenever a company, an organization, especially a large-scale organization like Google, releases a particular feature, it's generally not for every user. What happens is there is this concept of A/B experiments. So what they do is that they divide the users into two groups, group A, group B. And it need not be 50-50 cut. It could be 5%, 95% cut. So let's say if there's a new feature that they want to test, then they might, let's say okay, we'll just test it on this 5% users, and we won't test it on 95% users. And let's see how it goes on that 5% users. And if we are getting some promising results on that, then maybe we can expand it to the other 95% users as well. So a lot of A/B experimentation that happens in the organization. So I don't know if you guys have ever observed this, but on a lot of application, usually happens that a particular user, like I'm seeing a particular feature on a website, but my friend using the same website doesn't have that feature. And it generally happens because of the A/B experiments that the companies run continuously to analyze. And when they release it for a particular set of users, let's say 5%, then they analyze how is the user responding to that particular feature. Is the user taking it positively? Is the user using that feature, or is he not using that feature? So the benefit of this is that you avoid taking risks. If let's say Google or any other large scale organization releases a particular feature for, let's say, 100 million users, then it can lead to some disastrous results with some real problems. So they don't generally go about that in that way. So they use some kind of statistical sampling, and that statistical sampling can be as simple as releasing a feature for a country. Let's say Amazon says ki, I need to release this feature in Amazon India, but I won't show it in Amazon USA. But it can be also extremely complicated. For example, on Udemy, if you go, then the prices are always changing. One day I view C++ course, it cost me about 600 rupees. The other day I came, it just costed me about 800 rupees. So these prices, how do they come up with these numbers? These are not random numbers. So they analyze the user behavior. They take your data, like your location, your devices. Like, for example, an iPhone user might be much likely to pay higher price than, let's say, a web user or some other user, or a user using a high-end Android device. 1,70,000 rupees phone it will pay a higher price as someone who's using a basic 10,000 rupees phone. So these are some of the factors and some of the data that the company or an organization collects, and it displays you the pricing or a particular feature based on that. So I think almost and apart from these pub subsystems, there can be other things, like Sampath was explaining about how we split the data, because let's say if I have a 1 terabyte of data, I can't load it in the memory all the time, or it's a slice the data into multiple chunks and we process it one chunk at a time. Apart from that, let's say you have a lot of data in your database, but it might not always be and database, when I say database, let's say MySQL, there the data is actually stored on a disk, a disk storage, and we know that fetching the data from a disk is obviously much more expensive and time the data from memory, that is RAM. So you can use maybe some kind of caching there, something like Redis or Memcache, to cache your data before you actually use it. So that, for example, if there is, let's say, a data that you need to use it on multiple models, or multiple applications or scripts are trying to access the same kind of data, so you do not have to maybe fetch the data from MySQL, let's say, million records every time if it's getting used again and again. So maybe you can store that data on something like a Redis cache, or any other caching system. So these are some of the technologies or some of the solutions that people use on industry levels, and there's a lot of workaround. So basically, the point of explaining this was that students who are actually trying to get into machine learning, obviously mathematical concepts are important. Learning machine learning is important, but again, as a machine learning engineer on in the industry, you need to know a lot of system design and a lot of software engineering to actually implement these models on scale. So yeah, you can move to the next slide. So yeah, so I think what could be a good way of cultivating a, a strong machine learning environment for students. So the best part about like what we have today these days through internet is that there are a lot of competitions. Like for example, students are these days very much aware about algorithmic competitions like Code Chef, Hacker, and Code Forces, and a lot of other things. And there are a lot of hackathons and coding contests that go in our college. But then apart from that, I think there are a lot of contests that go on Kaggle, Crowd Analytics, Analytics Vidya, and students, I think, need to and they should participate in this contest, and it can help them gain a lot of exposure, a lot of different insights. And here, some of the contests are held by some really good companies and organizations that provide internship opportunities to students, based if you perform really well on Kaggle, and there are some cash prizes as well, and a lot of other benefits. So, and also I think college can organize and promote hackathons. Like we have a lot of hackathons and a lot of project competitions. So I think maybe we can have more such things which are solely focused on machine learning and machine learning hackathons. Maybe we can distribute, or we can come up with problem sets which can help them solve some interesting problems. And also, one thing I would like to say, that it's not necessarily like compulsory that you have to build what everybody else is building. For example, like a lot of students in their final year projects choose something like a stock price thing, or something, a property price, or it could be anything. So I'm not saying these are bad projects. These are definitely strong and good projects. But then again, you don't have to be restricted to these standard topics, because a lot of people do it because there are a lot of resources available, a lot of tutorials on YouTube, a lot of open source projects available on these lines. But then again, it's also important to understand where your interests are. Maybe if I enjoy like football, let's say, then maybe I can build some machine which will analyze a user's taste in music, something like Spotify does. Or I enjoy watching movies. Maybe I can try to build or think about building something similar, or something prototyping something what Netflix or YouTube is doing. So the entire point was key. You don't have to restrict yourself to the standard topics. You can obviously think and explore, and see where your interests lie and choose the topic accordingly. And I think, yeah, there should be more internship fairs, and there are a lot of websites and like Internshala, which provide internships to students. And a lot of these internships are work from home internships, so they won't have problems with attendance and managing between college as well as internship. So I think these internships should be promoted, which will definitely help them to land a full-time job as a machine learning engineer. And I think a general math sessions could be conducted, maybe like based on statistics, linear algebra, probability. And there is a and again, there are a lot of other competition like GSOC, Google Summer of Code, and GSC, which promote. These are communities which promote open source development, machine learning development. So I think these are some of the options that students can explore and benefit from it. I think uh, I think we're done.
I think,
Yeah.
uh,
So I think if you guys have, I think we have extended the session to
yeah,
40 minutes. We're just sorry if we took too much of your time, but if you guys have any questions, or we can just wrap it up quickly, I guess.
yeah.
If anyone has any question, I request them to put it in the chat.
Okay.
Maybe we'll wait for 5 or 10 seconds and then wrap it up.
Yeah, yeah. Sure, sure. We can wait for a minute and see if anybody has any questions, and give us some feedback if you liked it. If you did not like it, we'll appreciate it.
Yes, feedback, of course, we'll be taking formal feedback and sharing it with you.
Sure, ma'am.
Yeah. And it was nice. Thanks for giving us this opportunity
Yeah.
to.
Yeah, just a moment. We need to have a vote of thanks. Just a moment.
Thank you, Gautam, Sameer, Sampath, for sparing your time for this informative and knowledgeable session leading introduction to data science and machine learning. On behalf of the whole organizing team of FDP, I would like to express my gratitude for this wonderful session. We have one more session today on the topic hands-on NLP sentimental analysis by Dr. Vinayak Vari at 3 p.m. Link is already shared with you all. You all are requested to join this session on time. Thank you.
Yeah. Okay. Sameer, Sampath, Gautam, thank you very much.
Thank you, ma'am. Thanks a
Yeah.
lot for
Yeah.
giving us this opportunity.
Yeah.
Thank you.
Yeah. Bye. Bye. Thank you.
Yeah. Bye bye. Thank you.
Bye.
Thank you. Bye.
Thank you.